Hello guys, many of you asked me about the question number 4 tutorial 1.3, so here's a video for you. I'm not going to tell you about every step of the calculation, just want to explain on what's exactly happened in the question statement. Okay, we read the question and then we know that we are given a ferrum solid, okay, ferrum solid, and the mass is 1.55 gram of it. Okay, this solid is dissolved in acid solution. Once the ferrum solid dissolve, okay, it is converted to Fe2 plus aqueous. What's next? All this, once it is dissolved, all the solution is poured into a conical flask. So here is the ferrum 2 plus that we made earlier in this part. Okay, so this ferrum 2 plus is now titrated with 0.02 molar of KMnO4. And then we know as well, in KMnO4 we have K plus and Mn4 minus. We titrated the Fe2 plus with here, okay, I just draw here, the volume is 9.25 ml. Okay, once 9.25 ml of KMnO4 is poured into this conical flask, so Fe2 plus is oxidized to become Fe3 plus, and then the MnO4 minus is reduced to become Mn2 plus. Okay, this is what happened in this titration process. Okay, because the question only mentioned about MnO4 minus, so we can neglect this part, the potassium part. Okay, now the question asks you to write the balance equation for the titration. So titration part is this part. This is the titration part. Okay, titration part. Just write the equation, the balance equation. So we are using, because this is involve redox reaction, so we balance the equation by using ion electron method. Okay, and the solution is given you in acidic, therefore we are going to use this acronym SOHCAC to balance equation 1 and equation 2. Okay, so separate, we have settled the separate part, first equation, second equation. So next you do AOH until you combine and you get the overall equation in acidic medium. Okay, for part B, calculate the percentage of iron in the sample. So the question asks you about this iron. Okay, what is the sample, sorry, what is the percentage? From this information, the concentration and the volume here, okay, this is the concentration of KMnO4, this is also the volume for KMnO4, so we can figure out the number of mole of KMnO4. Okay, by using this formula, just remember that the volume here is in liter, so you have to convert this value, okay, and then put in this formula, so you will get the number of mole of KMnO4. Okay, we know that based on this equation, okay, we know that 1 mole of KMnO4 is equivalent to 1 mole of MnO4 minus. Okay, so once you get this value, let's say I note it as x mole, so you will know that this x mole of KMnO4 is equivalent to x mole of MnO4 minus. Okay, once you get the balance equation here, okay, overall equation, okay, you get this equation, so we can do stoichiometry for Mn4 minus. Okay, so I from the equation, okay, from the equation, how much mole of MnO4 minus is equivalent to how much mole of Fe2 plus. Okay, so this x mole of MnO4 minus is equivalent to, let's say, z mole Fe2 plus. Okay, so from here, z, okay, from here you can calculate. Okay, just continue your calculation so that you can get the percentage of ferrum by using formula of percentage yield. Okay, that's all the best.